Audio Jungle. Audio Jungle.
It's a composite bars, or it is also called compound bars. What are that? I mean, the same name we have here, okay? But what is the composite or compound bars? So if the bar, okay, made up of two or more materials, then it is called as composite bar or compound bars. More than one materials means generally we had seen bar, prismatic bar, which was only one single material, okay. But now if you talk about composite or compound bar, it means the bar bars made up 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 to two or more materials. More materials are called composite bars or compound bar. Simple. Now I'll show you, this is what simple bar. And here we have a composite bar. Okay. Simple bar means any bar which is made by one material called simple bar. But once I will talk about the composite bar. So composite bar means the two different material. This is one material used here, and now here another material used. So basically this is material 1, and here this is material 2. So two materials are used here, hence it is called composite bar. Okay. Consider one composite bar, and if load is what applied, okay, if load is what applied to this bar, so obviously this bar, whatever the load is what applied, this bar not a single material made bar, this is composite bar, hence both side material 1 and material 2 will share the load. If any load will be applied to this composite bar, then that load will be, or stress will be, shared by this two material, which is nothing but M1 and M2. If just example I will show you, suppose this is the composite bar here, check. Now this is the composite bar, okay. I can show you here. For this composite bar, obviously it is made by its different materials. Okay, and here load is nothing but this is nothing but load, right? Bar, different material M1 and M2. M1. Suppose load is what applied P. Load is applied P here. Now very important, this load load P1 will be load P1 will be shared by this material M1 and load P2 will be shared by material M2. So what is this total load applied? That is compressive load obviously. So whatever the load is what applied to this P, so it will be shared in between two, P1 plus P2. P1 will be the load shared by the material 1 and P2 will be the load shared by material 2. Okay. Remember this is this equation I'm writing, this is equation number 1. Okay. And if you go to second one, so here it is at the end, it is completely clamped, it is fixed. There is no slip in between these two material, there is no slip. So whatever the elongation you will get in material 1, you just say, because here the length is nothing but L for this particular material, so obviously for both length will be L, without any doubt, it will be L. But suppose there is the increment in length because of, or decrement in length because of the load. It's depend on nature of load, compressive or tensile. So whatever the change in length, obviously two different material we have M1 M2, but whatever the change in length, maybe it is shorten the length or maybe it is elongation in length, but in both material change in length will be delta L1 and delta L2 must be same. Why? Because it is fixed at this end. It is not going to slip. There is no slip between material 1 and 2. It is completely clamped. So in are held securely. Okay, the ends are held securely means there is no chance of slipping between that two material. So for that reason, change in length between the material 1 and material 2 must be same. This is the important note. Okay, this is the important key point for the key points for the compound bar. You please remember, this is very important what I am explaining, and in examination they are asking compound bar. Okay, based on this two, we have to solve the problem also, and they are asking problem in examination. It's very clear. Now coming to this, you know very well, change in length for any bar. What is change in length? If load is what P, suppose this is the bar now, this is the bar. If load, you are applying P load, this length is nothing but L.
PL upon AE.
Right. So whatever the change in length, that is, suppose delta L. So delta L is nothing but simple. It's a delta L is nothing but PL by AE. What is A? A is nothing but cross section area. E is nothing but Young modulus, that is material property. P is the load, L is the actual length. So now change in length, that means very clear. It's a delta L1 is equal to delta L2. That means P1 L1 divided by A1 E1 is equal to P2 L2 divided by A2 E2. This is very special relation, and always remember, with the help of this question will be asked, so you need to remember this key points. Okay, this key points came from delta L1 is equal to delta L2, that relation, and obviously this is for the compound bar. You need to remember that. Done. Anyway, now as you know, delta L1 is equal to delta L2, hence we got P1 L1 is equal to P1 L1 by A1 E1 is equal to P2 L2 by A2 E2. Based on this, we'll solve one problem, simple problem, and we'll see, like, how this formulation or how these key points what we have written here we will use and we'll solve the problem. We'll see it. Okay, so problem number 1. For this compound bar, problem number 1, we have here, it's a compound bar of length, it's a compound bar of length 600 mm, consists of a strip of a consists of a strip of aluminium 40 mm wide and 20 mm thick, 20 mm thick, and a strip of steel 60 mm 60 mm wide by 15 mm thick, rigidly joined at the ends. If elastic modulus of aluminium and steel are 1 into 10 to power 5 Newton per mm square and 2 into 10 to power 5 Newton per mm square. Determine the stresses developed in each material and the extension of the compound bar when axial tensile force of 60 kilonewton acts. Yes, little bit lengthy because formation of question is obviously it will be lengthy because it's a compound bar, but it's a neat and clean all data they have given. They said compound bar of length 600 mm, so obviously for both material length will be 600, that is common. Consist of strip aluminium 40 mm wide and 20 mm thick, this is the one material, and a strip of steel, this is the another aluminium and steel. Aluminium size they have given 40 mm wide and 20 mm thick, and steel 60 mm wide, okay, and 15 mm thick, rigidly joined. at the ends. If elastic modulus of aluminum they have given and steel, both young modulus they have given steel as well as aluminum, determine the stress developed in each material and the extension of the compound bar. So extension of compound bar, you know very well, it will be same for both material. So need to calculate delta L, and that will be same for the each material as well as for the compound bar. When axial tensile force has been given, that is 60 kilonewtons. Okay, obviously this problem will be very easy now. This is very easy now. It is clearly mentioned that compound bar length is given, which is nothing but 600 mm. So I will show you. Okay, I will show you that 600 mm compound bar, and it is clearly mentioned axial tensile load is given.
Sir,
Okay, so once we'll start solving this problem, so I told you this compound bar length is nothing but 600 mm it is said. So you take, because it's a tensile load, so yes, you just fix one side and just make this bar length is nothing but 600 mm. You can show like this. This is what 600 mm, and tensile load here it is clearly mentioned, it is given 60 kilonewton, right? Now this compound bar is what basically made by two material. It's nothing but aluminum as well as steel. So made by two material. You say this is what aluminum L, and this is nothing but steel. This is nothing but steel. Okay, aluminum and steel, correct. Now so obviously you apply the key points for the compound bar. If you remember key points for the compound bar,
P1 by P2 क्या आ रहा है इसमें?
yes, P is equal to P1 by P2,
0.44 आ रहा है क्या?
0.44. It's not calculated, it's okay, you just find the final value, we'll see it. No, the key point is nothing but total applied load is equal to P1 plus P2, that means P of aluminum and P of steel. This is the first key point. What is the second point? The change in length in both aluminum and change in length in steel must be same. This is the key points that you know very well, right? Anyway, so now we'll start solving this. So if you say change in length in aluminum is equal to change in length in steel, so we have P1 L1 divided by A1, E1 is equal to P2 L2 divided by A2 E2, right? So onward we'll put all the value because they have given. So we can say P1 L1 instead of P1 L1. I can say P aluminum L aluminum, area of aluminum E of aluminum is equal to P of steel L of steel, A of steel, E of steel. We can take the ratio. We can take PS steel by P aluminum. Check what is the value now. It's L aluminum divided by L of steel. Okay. Then AS, area of steel divided by area of aluminum. Okay. Then Young modulus of steel divided by Young modulus of aluminum. This is the ratio now. Check it. PS by PAL. So it's nothing but L divided by L, area AS by AL, right? ES by S, correct. Now keep all the value and you check. It's a PS by P aluminum. So obviously length of aluminum and length of steel must be same. There is no doubt about it. So it's a 600 by 600 because it's a compound, so both length will be same. Here you can check both length is what same for aluminum as well as steel. Now area of the steel and area of aluminum, that we need to write. Okay, so what is the area? It is given, check. If it is not given, we need to calculate. No, if it is not given, then we need to calculate. How will calculate here? See, they said for the aluminum 600 length is given, but what about the, this is the length, but how you will get the area? So width they have given. Okay, if you check dimension, it is clearly mentioned for both. They said aluminum 40 wide and 20 thick, 40 wide and 20 thick. So obviously you will get the area, because area is nothing but cross sectional area you have to write. So this is the aluminum. This is nothing but, see, okay, if you clearly see the problem, they had clearly mentioned aluminum 40 wide and 20 thick. So I can assure you this is the 20 thick, and this 40 wide. Okay, means this is the 40 Okay, there should not be any confusion. So area of steel is nothing but 20 into 40. It's a 800 square, right? This is all
The
about,
area of aluminum 20 into 40.
correct. If you go for the area of steel, right, area of steel, then 60 wide and 15 thick. So 60 wide means, I'll show you. 60 wide means just it will go in this way. Okay, bottom side, because this is nothing but steel. So length is same. Okay, so length is same, that is 60 wide and 15 thick. So 60 into 15 will be the area. So area of area of aluminum, this one is the area of aluminum, right? 40 by 20. 40 by 20 is nothing but area of aluminum. Sorry, this one please correct it. This is the area of aluminum. Area of aluminum. If I write area of steel, so clearly it is given 60 by 15, means it's a 900 square. You just keep this data here. So area of steel is nothing but 900. Just now you got area of aluminum. Just now you got, it's a 800. And young modulus of steel is given here. Na? It's nothing but 1 into 10 to power 5. That is for aluminum, and steel is 2 into 10 to power 5. Steel is nothing but 2 into 10 to power 5, right? So steel is nothing but 2 into 10 to power 5 divided by aluminum. It is given 1 into 10 to power 5. Now you have to solve it. So if you solve, then you will get PS by PAL, steel by aluminum. 600 cancel out, 9 by 8 into 2. 9 into 2 divided by 8. Nothing but, I think, 2 point should be 2.25, I think.
2.25.
Right.
Yes, sir.
Correct. So PS is nothing but 2.25 of P of aluminum. Now it is very easy for you, because this equation you can take it second equation, and first equation you can consider from the key points. This is the first equation. Use these two equations. So what we have P is equal to P aluminum plus PS. So P aluminum plus PS. What is PS? 2.25 of P aluminum. So you can take P aluminum common, 1 plus 2.25 is equal to P. So what is the P aluminum? Load on aluminum shared P upon 1 plus 2.25, that is 325. What is total load applied? It is 60 kilonewton, right? It's a 60 kilonewton. So 60 divided by 3.25. If you calculate load shared by the aluminum, so load shared by aluminum, if you calculate, it's nothing but, because it's a 60 kilonewton, so 60 into 10
18.46.
power 3 you can write. So this value is nothing but approximate 18462 Newton. This is the load shared by the aluminum. What is the load shared by the steel now? If you calculate load shared by the steel, so PS is nothing but P minus PAL, 60 10 power 3 minus 18462. Approximate this value is nothing but steel. This value is nothing but 41538 Newton. This is the load shared by the steel. Now once load shared by the aluminum and steel is what clear, then obviously stress you can calculate, because they are asking stress in each strip, right? They are asking the determine the stresses developed in each material and the extension also they are asking. So first we will calculate stress. Now what is the stress in aluminum and what is the stress in steel? We can separately write stress in aluminum, that is nothing but sigma AL. Load in aluminum, load shared by aluminum divided by area of aluminum. Separately you have written aluminum area is just now you have calculated 184. What was that? 18462 divided by what is the area of aluminum? Just now you have written area of aluminum is 800 mm square. So sigma of aluminum will be nothing but, that is the stress in aluminum aluminum strip is nothing but almost approximate to 3.08 Newton per mm square, because this area is what, 800 mm square, hence don't change unit, you just put in that way only. So this is nothing but stress in aluminum. What is the next stress in steel? If you go for the stress in steel, so what is the stress in steel? It's nothing but sigma s PS divided by AS. What is the PS? If you remember, it was 41538 divided by area was 800. No, I think 900. 900 for the steel. If you calculate sigma S, it's nothing but stress in steel is, now if you calculate, it's approximate 46.15 Newton per mm square. Okay, this is nothing but stress in the steel strips. Okay, because compound bar is what made by two different material, steel and aluminum. Now what is the change in length for the compound bar? So as I told you, second key point, it was delta L1 is equal to delta L2, meaning is aluminum and steel must be same. So for anyone you can calculate, I am calculating delta L for aluminum, so it's nothing but load of aluminum, length of aluminum divided by area of aluminum into Young modulus of aluminum. Keep all the data here. So check what is the load, a load shared by the aluminum. Just now you have seen 18462, no? 18462, 18462. Length of aluminum is 600 mm length, you know very well. aluminum area, if you remember, 800 into young modulus of aluminum, I think 1 into 10 to power 5, I don't 1 into 10 power 5, right? 1 into 10 power 5, 1 into 10 to power 5. So now if you calculate the change in length, so it's nothing but delta L aluminum, you will have
0.31.
0.138 mm, right? This is nothing but change in length of aluminum, and this will be for the complete composite bar also, because whatever the change in length in aluminum will be the change in length in steel, that we already know, and that is nothing but change in length for the compound bar, which is same, it is nothing but 0.138 mm. This is the final answer for this type of compound bar. If question came based on this, we have to process.